Now that we've implemented resize, our array list will work correctly. So whatever we throw at it, it will properly handle the operations we ask it to do. So let's do a little speed testing. What I got right here is a class called speedTestAList. It creates an A list, and then it adds 100,000 items to it using our addLast method. I also have a similar test for the S list from last time. And so I'll start by running that one. I won't show the code because it's basically the same thing. So when I do Java speed test slist, we see it is very fast. In fact, I can use the Linux time command to run it and see just how fast it is, and we see that it is very fast indeed. By contrast, if we run the A list speed test, we see it takes quite a long time, 3 seconds. 3 seconds is actually quite a long time for a modern computer to add 100,000 items to a list, and is obviously much worse than our S list. So why? Well, I've got a little puzzle for you to work our way towards understanding. So let's suppose we have a full array of size 100. If we call addLast 2 times, the question is, given that totally full array, we know it's going to have to resize twice. How many total array memory boxes will we need to create and fill to actually accomplish what we want? And I have a bonus question here, which is, what is the maximum number of array boxes that Java keeps track at any given time? And let's assume in this case that garbage collection, the thing where an object disappears, happens as soon as you lose the last reference to an object. So maybe pause the video and ponder this. And so it turns out for both of these, the correct answer is in fact 203. Let's see why. So resizing twice requires us to do the following. The first time we resize, we create a new array of size 101, we copy everything over, and that takes up 100 spaces here, or we fill in 100 spaces, and then we finally fill in the last one. So that's 101 create and fills. We then repeat the exact same process, but now for 102. And so in this case, we can say that the total number of array memory boxes that are created and filled is 203. Likewise, the most array memory boxes that we have to keep track of at any given time is also 203. You might say at first, like, aren't all of these arrays around? But remember that during the copying process, as soon as we've finished copying everything from this array to this one, we can throw this array away. So in the worst case, you'll just have 2 copies of the array laying around and you won't have a whole bunch of them. Okay, harder puzzle. Let's suppose now we have a full array of size 100. And now let's say we call addLast until size is equal to 1,000. Roughly how many total array memory boxes will we need to create and fill? So ponder this question. I will now end the video in order to encourage you to actually do this problem. And there's the bonus question again, and I'll see you in that video.